Hello everyone. In this lesson, we're about to learn how can we input the deviation survey file, the well path of a well, and its data. So the well path, you have to, not only the deviation survey file, you have to upload the coordinates and the latitude and longitude. Okay, so this is an example on the screen. Okay, so the first thing you have to do is to load the log reference datum height to the sea level. It usually is the calibration or KV, but not always. Usually it's around calibration. Okay, then depending on the projection system you are handling, you should load the X and Y, the coordinates of the well. That means the east-west and the north-south. That depends upon the projection. Especially this is important if you are about to build a three-dimensional model or a simulation model or that purposes. And for your own mapping and other stuff. So this is a must-have. Another feature is to you should load. You are not obligated to do that, but it is very strongly recommended to load the well latitude and longitude. Okay. Well, this is the standard convention of science. So the is negative longitude means to the west, like the U.S. and Canada, and positive longitude are positive to the east of London, Greenwich Meridian. Okay, the same of latitude, positive is the northern hemisphere and south is the southern hemisphere. Okay, so once you have that basic information, you should upload the deviations on the file. This is the one example here. The first row has to be 0, 0, 0, 0, 0, 0. Well, it is assuming that you start the well as a vertical path, and later on you may tilt and navigate vertically or inclined or whatever. But usually the standard is 0, 0, 0, 0, 0. Okay, very good. Let's open some help on this. So that is the geometry help path. You log, you click the geometry help, and there is a help. So there is some help on the system. Okay, the latitude and longitude and the deviation survey file. So there are three formats that GeolOil reads. Okay, the default format is to have the very original deviation survey file, which is one column with MD, measure depth, one column with inclination, INC, it has to be the title, and one column azimuth, AZI. Okay, this is the default. That is the very default, the original deviation survey file path. Only three columns. Measure depth, inclination, and azimuth. Azimuth, AZI. Okay. In some cases, some companies, for some reason or another, some companies remove the inclination and azimuth, and they deliver something like this. They deliver measure depth, true vertical depth, delta X and delta Y, or east and west deviation, or north and south deviation from the center of the well, from the surface location. Okay, this is unfortunate because it sounds okay, but it is not okay because it removes the information of inclination and azimuth, which is very important. There are you can have equivalent well paths different than this one that find with the same delta x and delta y. Okay, so you can go from your location to London using three planes touching three different airports in three different countries, or take another route. So the final delta x and delta y might be the same, but inclination and azimuth is not. So there is a miss of information. If you know that information, you will process it and will be happy to process it. But it will try to iterate and make some error correction and some minimization of errors, and will try to rescue the possible inclination and azimuth. So you want to read something like this. But the answer is not unique. As I told you, if you have only this information, there are several inclination and azimuth paths that will reproduce almost exactly the same delta x and delta y. There are several paths that you can take to reach the center, delta x and delta y, and TBD. So the solution is not unique, but the solution of GeolOil will be very, very accurate to this one, and we are going to see that. Okay, another format is this one. Some companies deliver the full well navigation for you. Some companies deliver measured all the five, no, 6 columns. The one column for measured and has to be that exact spelling. MD, measure depth, TVD, true vertical depth, delta x, dx, delta y, dy, north-south, inclination, INC, and azimuth, AZI. So if you input that information, your will honor exactly that information, and he will consider the deviation survey file, and it will make some internal verification, but it will try to honor as long as the information is correct. Okay, but the standard way is to use the original data like this one. Okay, we're about to check this more and more. And the format, the file format has to be, okay, has to end, has to be a text format, has to be end with sor.txt underscore sor.txt. That has to be a extension, a text file. So we'll be watching some examples with Excel, and we're going to export as a text file and see more on this. This is important. So unless your well is really very vertical, you should upload all the time the deviation survey files. Well, obviously, if you have a high inclination, and horizontal well, that is a must. Okay. Okay, well, this is the help on latitude and longitude. Okay, let's see that. Okay, I'm going to dismiss. Well, let me minimize this help. Okay, very good. Okay, so we have here an example. We have the north and south latitude. This is the northern hemisphere, and east and west longitude. This is an US well. I mean to the west of England, to the west of Greenwich, close to London. Positive to the east and negative to the west. That is the standard international reference. Well, and the reference for north-south is the equatorial line. Equatorial line. Okay, very good. So now you want to know, you want to verify, to compare, you have an idea if your well is correctly placed. You will be surprised how many times there are problems on the well coordinates and latitude and longitude. So many companies nowadays they have some high precision GPS, so they are updating continuous that information. Some companies have that coordinates in decades ago. For decades ago, some companies are running with modern GPS the latitude and longitude. Let's check an example. So we should click the Google Map button, this magenta or pink color, and it will connect with a Google Map server, and it will display for us, for you, will display where the location is, and hopefully you may even physically see the well, like in this example, and even a collection of wells. So let's see how it behaves. I'm going to click on this and see what happens. Okay, it's trying to connect to the Google Map server, and it's coming. Okay, very good. Okay, this is the location, but what about photographs, satellite photographs? So if you click on this button, it will pop out a satellite photograph of that. You click on that, oh, Viola. Wow, this is nice. Okay, let me make a zoom in. This is the location, and wonderful. This is the well. Let me see. Nice, isn't it? this is the well. You see even the trucks, they were making some jobs to the well or drilling or whatever they were doing. Very good. So this is one truck, another truck. That's it. This is your well. Very nice. If you zoom out, you you with some luck, you may see another wells. Okay, you see the street, and this is yet another well. You see this one? This is another one. Hopefully you see another one, and you see where you are. So this is another yet another one. Okay, cisternas, trailers, trucks, everything's there. Okay, so this is a nice feature. You should use all the time, and in some cases you will see that the latitude and longitude coordinates are not correct, and they have a mismatch from Google Maps. In other cases, we have seen also occasionally when Google Maps seems to have problems. If you do this, for instance, using Google Maps, you may have one picture, and if you compare that with Bing, the other the other tool, you may have a different location. So they are updating this. I don't know which one is correct. We usually have a high trust on Google Maps. Google is a very nice, wonderful program. Okay, so let me minimize this and keep working on that. Okay. Now let's go to the actual files. Let's go open here Excel. Okay, here to the right screen. Okay, this is a deviation survey file, the original one, where we have measure depths. MD has to be exactly that spelling, those two letters, MD, like that. Don't use dashes or underscore or dash or whatever. One column with the head measure depth, one column is inclination, INC, one column is azimuth, AZI. Okay, so so you have that, or someone gave you that information. Okay, very well. So as I told you, the format is not Excel. The format has to be exported from Excel to a format that is, I don't remember what that's dot sort. Okay, it has to be a text file with the extension underscore sort.txt. We're going to export that. We're going to export that and create this file. Okay, good. So this is the spreadsheet file. Okay, very well. You will go to File, Save As. Okay, exactly. Text that delimited txt. Um, okay, let's see. Save as this one. Okay, you have to save, measure depth, inclination, and azimuth in a plain text file. Okay, you save that. I already have it saved. Uh, Let me see where's that. And okay, this is the one. This is the one. So what is it? Oh la la. All right. Okay, you export from Excel to a plain ASCII text file, and you have this. You have one column for measure depth, one for inclination, and azimuth. Okay, good. Likewise, you have the same export for other formats. Okay. Okay, now we are about to upload that deviation survey file. So you hit here. Well, you can declare a well vertical if If the well is vertical, well, you don't need any information on measure depth, inclination, and azimuth. It's understood that inclination is always 0 degrees against the vertical line reference. And azimuth, well, should be 0 at any value should be okay. All right, so you hit here non-vertical, and now you should upload your deviation survey file. And this is the one, you remember. This is one, the first example. Measure depth, inclination, and azimuth. You open, it will read it, and it will make all the computation needed. It's quite fast. So these are the results. So, okay, it read measure depth, inclination, azimuth, and it internally computed TBD, delta X, and delta Y. Not only that, there are more computations. So you don't see here, but internally there are some TBD curves, TBD subsea curves, like something like that, an XY path. So everything, once you upload the deviation survey file, everything is there. Everything is there. It has all the information. You can add a curve like TBD and TBD subsea is working on that, and a curve on XY path. Because it has the deviation survey file. Now well, you may want to see that TBD to subsea, X path, Y path, delta X and delta Y path. You hit edit table, and that's it. So you have that full information according to the resolution of your log. In this particular case, every 0.5 foot, you have that. So you have a lot of information. When you navigate or make clicks on the well log, you have everything. All right. Now let's make a different exercise. Okay, let's suppose that for some reason you have only this information. You have measure depths, TBD, delta X, and delta Y, and for some reason the very original data columns of inclination and azimuth is lost. So the problem is that there are several inclination and azimuth paths that will reproduce quite similar or almost the same TBD, delta X, and delta Y. So the solution is not unique, but GeolOil will find for you, will compute for you one possible very close approximation, and it makes a very good work of that. Okay, so you should be able to export or save as a text file. Save as okay. Tab text delimited text txt, and this one. Export on that. I already have exported. Measure depth, TBD, delta X, and delta Y, and that's it. I'm going to cancel because I already saved. All right. Now I have here. Okay, this is the same well. Okay, this is the original with measure depth, inclination, and azimuth, and this one to the right. We're going to load the. Let's go to here to the end. I'm going to upload the deviation survey file with measure depth, TBD, delta X, and delta Y, and compare this with the original inclination and azimuth. Let's see what happens. Okay, load survey file to be text. This one. Okay, now open that, and it will take a while because it is not only reading. GeolOil will not only read that, but it will have to back compute the reverse engineering has to be compute the more or less the some similar inclination and azimuth. There are multiple infinite solution for that will reproduce TBD, delta X, and delta Y. So you will internally make an optimization, an error minimization, and will make a very good estimate for you. Usually, well, not all the time, but most of the cases it works really very nice. So you hit open, we'll start to compute. It's working there. Let's see what happens. It is a heavy computation. You have a quite large deviation survey file. It might take minutes and minutes. Okay, but not in this example. This example is not a huge deviation survey file. So let's see what happens towards the end. Okay, very good. Let's go for the very last row. You see, compare here with this one. So measure depth, TBD, and delta X and delta Y are obviously the same because they were red. But inclination and azimuth was missed in the original. So the back computation gives a similar value to the real correct original one, which at this depth was 6.4 degrees, and it back computed 6.58. Remember that GeolOil does not know what is the correct information, and there are several paths that reproduce the same delta X and delta Y and TBD. So this is very close to the original, completely useful. So for navigation, for 3D mapping, for simulation, is really what you need. Measure depth, TBD, delta X, and delta Y. But try always, as I told you, try to always to, to have the original information, measure depth, inclination, and azimuth. Okay, here is another example. Here is another example. In other cases, some company gives you everything and even more columns. And even more columns than this. This is the what we can call a full set. We have here measure depth. Check out the spelling. It has to be exactly that. TV, and even the uppercase, I think is sensible. Delta X, delta Y, inclination, and azimuth. So in this example, we have 6 columns. Okay, for the full pass, there is no unknowns there, and you should, if that gives the information, you will try to honor exactly that information as long as it's mathematically and geometrically consistent in 3 dimensions. It will honor that. If there is some information, you will complain, so will give you a hint of what is the possible problem. Okay, save as um, well, something like that. This is the full example. Okay, you said that I already have said, and if you did that, this is the last example, and this is the one. So in this case, it is exactly as the original measure depth, inclination, and azimuth. That means that whatever the company do, they use the same equations as you did. That's why all the values are exactly the same, or maybe, I don't know, maybe to the second or third decimal or something like that. So, well, that's it. That's it, everything for this lesson. So we learned how to upload and declare the well passes a well that is you need to upload the Kelly using the vertical reference height to the sea level, usually the Kelly Ocean. In some cases, ground level. In some cases, it's zero. You have a well offshore, it's zero. No? It's normal. The X and Y coordinates and the latitude and longitude. Remember the Google Map feature that's connected. You physically should be able to see the well. Again, this is the well, yet another nearby well. And you can zoom out and see where's the well. You can zoom out and see where's my well. Okay, good. Well, this particular well is close to the border between Canada and US, my 2 beloved countries. Very good. We have a branch in US and we have a branch in Canada. Okay, let's zoom out more and more. Okay, I think here this is the Great Britain Island. So this is around Greenwich meridians. To the west of that, to the east, we have negative longitudes, and to the right of that, to the east of that, we have positive longitudes. So from Europe and Russia and other countries, India, we have clients everywhere in the world. Well, not everywhere, many places in the world. They use positive longitudes. Okay, very good. Well, this is all for now. Thank you very much and enjoy your rest of the day. That's everything. Thank you. Don't forget to share this video, this information. Our software capability help us. And also please subscribe to our YouTube video channel. Thank you very much.